have identified power families, and so these are, to me, mental math skills up at the top. All you have to do is solve it in your head. So I'm not going to show you a method. These are the ones you should know the power families to help you on 306. So 2 to what power would give me 8? You should know that one in your head. So x has to be 3. These to me are all mental math type problems. How would I get number 2? 3 to what power gives me 9? 2, right? So y has to equal 2. What about number 3? 5 to what power will give me 125? It's cubed. So t has to be 3. 5 times 5 times 5 is 125. What about 4? 6 to what power gives you 1? Anything to this power gives you 1. Yeah, 0, right? 6 to the 0 power is 1. And the power family chart that I'm referring to is page 301. So there's not much learning on this page. It was just associating that like 2 cubed is 8, 2 to the 4th is 16, anything to the 0 power is 1, anything to a negative exponent is a fraction. So that's, maybe you just want to look over that if you didn't get a chance to do it. All right. I want to bump this recording. All right. This one, number 5, would be what? 10 to the first power, right? Anything to the first power will always give you back itself. And then on this one, this is the 1-to-1 property. If the bases are 5s on both sides, the exponents must both be 6 on both sides to make it true. So do you think if you were given a question like one of these on the quiz tomorrow, you could figure it out with some mental math? Okay. So the ones that get a little, what? Quiz tomorrow, yep. On some exponential properties and the stuff that we've been doing today. All right, so this time these are a little bit harder. You might not know these in your head, but you might. It's not -3, it is negative. Why is it -2? So it's squared, right, to get to the 9, and then the negative is what flips it upside down. Number 8, you might not know in your head. Let's see. 4 times 4 is 16, times 4 is 64. So it must be the 4th power, right? Okay. So it's the -4th power because 4 to the 4th is 256, and you're flipping it over with that negative exponent. The parentheses should be a little bit bigger. It's 1/4 to what power equals 16. So how do I go from 4 to 16? Square it, right? But then I'm going from the 1/4 to the 16. So again, it's a negative exponent. This went from a whole number to a fraction. This is going from a fraction to a whole number. So you need the negative exponent. So t has to be -2 because 4 squared is 16. Make sure you don't put 4, right? Because it's not 4 times 4, it's 4 squared is 16. All right, how about number 10? 7 to the 2x equals 49. So what would x have to be to make this true? What? 1, right? Because that would give you 7 squared, wouldn't it? So x has to be 1. All right, 3 to what power is 81? 3 times 3 is 9. Times 3 is 27. So times 3 is 81. So 3 to the 4th. So really what you're doing in your head is you're bringing the 84 down to the base of 3 that you can recognize. So then if 2x has to equal 4, what does x have to equal? X would have to equal 2 to make it true. And then for me on number 12, I can't do this in a one-step problem. So what I would do is leave 5 to the negative 1 alone, and I would rewrite 25 as a base of 5. So 25 is 5 squared, and it's got this x power still sitting out there. What's the rule when I distribute a power? Remember that I multiply them together. So I really have 5 to the negative first equals 5 to the 2x. This is the one-to-one property. If the bases are the same, you can set the exponents equal to each other and forget about the base. So how am I going to make negative 1 equal 2x? Or how am I going to make 2x equal negative 1? How would I solve that for x? Yeah, divide by 2, right? So x would have to be negative 1/2. I couldn't have gotten that myself from the beginning. Maybe you could have, but I like to make the bases the same so that I can just worry about the exponents. Kind of like over here, if the bases were the same, and 2x would just equal 4. So I'm going to have you do the back page first so that we can go through kind of these. This is the fractional exponent rule. Maybe we should review this for people who weren't here. Let's just quickly do D and I together just to set people up for the fractional exponent rule. We did this on page 305. See how it says 305 to 306 guided practice? So what does a fractional exponent do? Can you explain it to someone who wasn't here? What does it put into the problem? Begins with an R. A radical. So it puts a radical into the problem. The denominator, which in this case is 2, is the index of the radical, and then 9 cubed is going to go under the radical. And I don't know 9 cubed in my head, but I know that the square root of 9 is just 3. So if the square root of 9 is 3, now I can do 3 cubed in my head. So 3 cubed is 27. So 9 raised to the 3 halves power is 27. Were you here for fractional exponent rule? Okay. Okay. So then negative 27 in this case is going to go under the radical. 3 is the denominator. So 3 is the index. And then I don't really care about the first power, but I wrote it there anyway. Can I take the cube root of a negative number? Because it's an odd root, you can. Because a negative times a negative times a negative will give you back a negative. So the answer would be what? Negative 3. So I'd like you to try this page first. So this is working on just the fractional exponent rule and then solving some of these. I call them simple exponential equations because you can do them with mental math. There's some others that you can't do with mental math. For example, how do I get 2 to the x to ever equal 10? That's not a perfect power of 2, right? So the answer is going to be a decimal. So we need to learn a strategy to do this type of problem. But right now, all of these should be perfect powers. So take a couple minutes and try this page, and then we'll put the answers up. Okay, so we know 4 cubed is 64, hopefully. 2 to the negative third, you flip it over and cube it, right? So 1/8, and it should be positive 1/8. It doesn't change the number to be a positive or negative number. And then this one should have been the square root of 100, so that one should have been 10. Is that what you got? Make sure that you just wrote the number 10. It's not the square root of 10. The square root symbol you just did. So it should be just 10. Let's see, the cube root of 8 squared. So the cube root of 8 should have been 2, and then 2 squared is 4. Did you get that one? Let's see, the cube root of 1,000 squared. The cube root of 1,000 is 10, and then 10 squared would be 100. And then 2 to the first is 1. So we did okay on evaluating at the top. So some of you, the fractional exponent might need to be reviewed a little bit. And I think on the next page, if you look on kind of this number 8, there's 3 more practice questions with the fractional exponent. All right, and then down here at the bottom, solving these exponential equations, I think you should have gotten A, right? It's just 5 cubed is 125. And then how do I go from 6 to 1 over 36? It would be the negative second power, right? Because you're squaring it and flipping it over. This one is tough. How would I go from 100 to just the number 10? Not thinking about the fraction. The fraction just makes the answer negative at the end. It's the 1/2 power is how you go from 100 down to 10 because it's taking the square root of 100. So the answer is negative 1/2. If you're not sure how to get there, what you can do is you can just focus making either side of the equation just 10. So 100 is 10 squared to the x. So you could have 10 to the 2x on the left. And then this is 10 to the negative first power. And then once you have the bases the same, if you say 2x equals negative 1, the answer is negative 1/2 when you solve it. So when you can't do things in your head, try to make both of the bases the same base, 10 and 10. So 10 to the 2x and 10 to the negative first. So kind of the same thing on part D. If you want to make these bases the same as each other, 32 is what power of 2? So you can go back to your power families, or you could just count up on your fingers. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32, so it's 2 to the 5th. So if you have 2 to the 3 plus x equals 2 to the 5th, what does x have to be to make it true? X has to be 2 to make this statement true. And then anything to the 0 power is 1, right? So x has to be 0. Does that make sense on that one? Anything to the 0 power will get you 1. And then f is tricky. So what I would do is I would try to rewrite both of these with a base of 7. 49 is 7 squared, right? And then it's being raised to the x. 2 times x. So 7 to the 2x equals, how can I rewrite 1/7 as a base of 7? It would be 7 to the negative first power. Then you can set your exponents equal to each other. So this time it's going to be negative 1/2 again, isn't it? 2x equals negative 1, divide by 2, x equals negative 1/2. So there might be like one of those more challenging type problems, but certainly a couple of the ones that are like the mental math type skills. And there's a few of those to practice on the 7th I can statement for the quiz.